Hello, we're going to be doing 4.5 notes today, the very last section of chapter 4. So isosceles and equilateral triangles. So our objectives, we will be able to find missing angles and sides in equilateral and isosceles triangles, and students will be able to classify triangles by side lengths when given coordinates of vertices. Okay, we're going to start with isosceles triangles. So an isosceles triangles has at least two congruent sides. So the parts of the isosceles triangle, the two congruent sides, are called the legs. The other side is called the base. The angle included by the leg is called the vertex. And the angles that have one side that is the base are called base angles. Alright, and then we can see everything labeled here inside our triangle. We have the two sides that are the same length, and we can also tell they're the same length because they both have two dashes in them, which means they are the exact same thing, and they are called the legs. And we have the vertex angle, the base angles, and then the base itself. So the thing to remember about the base, it's not always at the bottom. There's going to be times, let's see, I'm going to scroll down to the next page real quick. There's going to be times like number 2 where the base is not at the bottom, but this is still the base because these two are the legs. So the base doesn't necessarily mean at the bottom, it just means it's not one of the sides that is the same. Okay? Alright, let's go ahead and go back here. Alright, so we're going to do the first exploration. So I have it pulled up. Let me grab it. So what we need to do is move the vertex around. We need to pay attention to what happens to the lengths of the sides, what happens to the angles, and all that kind of stuff. So right now we're at 5.8, 5.8, 6.01, and the two base angles 54.51, 54.51. Alright, so I'm going to move this angle. Oh, that got a lot bigger quicker. Alright, so now we have 12.6, 12.6, 59.32, 59.32, and the bottom is 12.85. Let's move the top one. Okay, we're at 13.46 on both sides, 18.33, and then 47.08 on both of the base angles. Let's try moving C a little bit. I can't move it inwards. Just move it around. Let's move it over there. Alright, so we have 13.46 on both sides, 25.52, 18.54 for both of those angles there. So remember, an isosceles triangle means that the two sides have to be the same. So we have our two sides that are the same, and then we're also taking a look at these angles. So I want you to take a second to think of what do you notice about these angles. No matter where I move my triangle, take a look at those angles again. Let's try expanding it this way. Okay, so what do we notice about those angles? What I notice about those angles is that, no, not quite there, the conjecture. What I notice about the angles, if the legs are congruent, then the base angles are also congruent. Alright, so that is called the isosceles triangle theorem. So if two sides of a triangle are congruent, then the base angles opposite those sides are congruent. So if we have the matching sides, which we have here and here, then we have the matching angles, which are across from the two sides. So remember, the two sides are here and here, so it matches up right down, so they're across from the two sides. Alright, then right below is the converse of the isosceles triangle theorem. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's just pretty much the other way. So converse is the opposite So it's the same thing, you're just switching the statement around. So if we think about if-then statements, we have if one thing, then another. In this case, we can switch them, and they're still true. So we have these two angles, and then across from the angles, the sides would be the same. So that's what these are showing, with the angles to the sides. Okay, let's go ahead and try a few examples. So we want to find the measure of every single one of the variables. So for example 1, so we have our two legs, right? So that means if those are the same across from them, the angles have to be the same as well. So this angle is 63, which means this angle, y, also has to equal 63 degrees. All right, and then we need to find x. So yes, x is not going to be 63 because it's not across from either one of those sides. So we're going to have to remember the sum of a triangle. So all the angles add up to 180. So that means 63, sorry, move up a little bit, 63 plus y plus x equals 180. I know y is 63. And you can automatically put the 63 in if you want, but I was adding up all the sides, y is 63, so we have that. And I have 126 plus x equals 180. Subtract 126 from both sides. I get x equals 54. Okay, so I have both my variables there. Okay, let's take a look at example 2. So for example 2, we have our legs, and then across from our legs, our angles are going to be the same. So this means that A equals B. So they are the same number, but we don't know what A is, we don't know what B is, so I can't really go any further than A equals B, but I need to figure out some sort of term for them. So I'm going to go back to the triangle sum theorem. 35 plus A plus B equals 180. Since A and B equal the same thing, I'm going to make these the same variable so I can combine them. If you want to make them both x, or you want to make them both b, or both a, either way, as long as they're the same variable, because we know that they're the same. So if we just show that they're the same, because then now we can combine these. So I now have 2a. Okay. I'm going to move up here so I have slightly more room. So I'm going to go ahead and subtract my 35 from both sides. I now have 2a equals 145. Now go ahead and divide by 2. A equals 72.5. Okay. So if A equals 72.5, so remember A equals B, which means, let's change up the color, B also equals 72.5. Alright, so I decided to use A plus A, but if you wanted to use a completely different variable so you didn't get confused, as long as you knew what you were working with. And since we knew that A equals B, I just knew I had to combine it some way I did here. Alright, so I'm going to give you a second to try number 3. Go ahead and pause the video, try it, and then after a couple seconds it should pop up. Alright, so here's number 3. D is 71 because it's the other base angle, and then I had the triangle sum theorem to get E. Okay, let's go ahead and take a look at number 4. So this time it's talking to us about angles. So these two angles are the same. We don't have, we're not trying to find a variable for this angle here, but it is important to recognize, well, this also equals W degrees. Anyways, so across and across, so we are finding an angle and a side length. figured I'd start with the side length and review that. So if we have angles, the sides across from them are equal, so that means z and 7 are the same, which means z equals 7. So just like if we were going from the sides to the angles, it's the same way if we're going from the angles to the sides are equal. Alright, so now let's talk about the angles. So I've already brought up that over here is also w degrees because they're both the same. So in order to find w, I'm going to have 95 plus w equals 180. So now I have 95 plus 2w equals 180 degrees. Go ahead and subtract the 95 from both sides, and I get 85. And then divide by 2, and I get w equals 42.5. Not bad, 5. There we go. Alright, let's go ahead and take a look at number 5. So let's go ahead and start with the side lengths again. So we have two sides going across from our congruent angles, which means the two sides are congruent, which means h equals 11. Alright, and then let's talk about the angles. So our two curved lines mean they're the same. So this side is also 70 degrees. So now I can use the triangle sum theorem. 70 plus 70 plus g equals 180. So now I have 140 plus g equals 180. Subtract 140 from both sides. G equals 40 degrees. Okay, so these last two problems were very similar to the ones we did up top, but the ones up top, sides to the angles, angles to the side, still the same process as long as you can see and verify that they are the same. Alright, so let's go ahead and try number 6. I'm going to give you a couple seconds. Make sure you pause the video and try them out, and then it should pop up here in a couple seconds. Okay, here is number 6. Go ahead and take a look. There's H and K. Alright, let's go ahead and move down to number 7, 8, and 9. I believe all these are connected. So we have triangle ABC is an isosceles triangle with base AC. So the base is here, which means these two sides have to be the legs and they have to be congruent to one another. So the base is AC, that is this side right here, which means the other two are the legs, and the legs are congruent. AC is 8, and AB, so this is B, AB is 7. Alright, so we want to find the value of x. So we have x here for angle B. So I need to identify what this other angle is. So I'm going to draw my arrows diagonally or across from the two sides that should be congruent. And so that means angle C is also 66 degrees. So I can now use the triangle sum theorem to solve for x. So 66 plus 66 plus 3x equals 180. So go ahead and add these two together. 132 plus 3x should equal 180. Subtract 132. Handwriting's kind of big, sorry. And then I have 3x equals 48. Divide by 3. X equals 16. Alright, so I have now solved for x, which is 16. So now I want to find the measure of angle B and angle C. So we actually had to find the measure of angle C in order to find x. So I can already say what that one is. So angle C equals 66 degrees. Alright, now I have to find angle B. So angle B equals 3x. We just found out what x is, which is 16. So angle B equals 3 times 16. So I just plug that right in. And then if we multiply those two together, we get 48. So angle B equals 48 degrees. Alright, and then we want to find the perimeter of triangle ABC. So the perimeter means you add all the sides together. So I have 8, 7. I figure out what the last side is. Since it's my other leg, I know that it's going to be 7 as well. Even though it didn't tell me, I know it's the other leg and both legs are equal to one another. So 8 plus 7 plus 7. We can get 8 plus 14. Add the 7s together and add those together. We get 22. Okay, let's go ahead and try some more. So find the value of x. We have our legs. I'm going to go ahead and draw my arrows. So those two angles are congruent. So 9x equals 72. Divide by 9. X equals 8. Alright, let's take a look at 11. So this time it's telling me the angles are congruent, so I'm going to go across this way. So 5x plus 5 is equal to 35. So I can go and solve for x here. Subtract 5. I have 5x equals 30. Divide by 5. X equals 6. Alright, and then I want you guys to go ahead and try number 12. I'll give you guys a couple seconds to pause the video and check it out. Alright, so there it is. The thing to remember, especially when you're dealing with the sides, is this third side doesn't matter too much. It's when you have the angles, because we know that all the angles add up to 180, but the sides don't necessarily have to add up to something specific. Okay, so I was just focusing on the two sides that would be congruent because we know those angles are congruent. Alright, let's go ahead and go to the next page. So equilateral triangle. If an equilateral triangle, or a triangle is an equilateral triangle if all three sides are congruent. So these have little dashes. I'm going to make them slightly bigger. So if all the three sides are congruent, it's an equilateral triangle. Alright, so the equilateral triangle theorem, if a triangle is equilateral, then it is equiangular. So that means if the sides are congruent, then the angles are congruent. So very similarly with the isosceles triangle, except for we had one less, but it's the same concept. Well, these are all the same, so the angles must also be the same. Alright, so then the converse of that, if a triangle is equiangular, then it is equilateral. So just the opposite of the last one. If we have the three angles the same, then the sides must be the same as well. Okay, so let's go to explore this. So what is the measure of each angle in an equilateral triangle? So if we draw a triangle, all these are the same. So I can just give them some variable. Let's go ahead and give them x. So if this bottom left angle is x, that means this and this one are also x because they're all the same angle. So remember, all the angles add up to 180. So x plus x plus x equals 180 degrees. Well, these are all the same variable, so I can combine them. I now have a 3x equals 180. So I can divide by 3. X equals 60. So that means each angle is 60 degrees. So when we're looking at these and we just have one angle, we don't have another angle, we're trying to find a third angle, something like that. We could still find it because in equilateral triangles, every single angle is the same, and that same is 60 degrees. Okay, so 13, and also wants us to find the perimeter. So find the value of the variables. So let's start with the angles. Angles are usually some of the easier ones to start with. So each angle is 60 degrees, which means B has to equal 60 degrees. All right, and then all of the sides are the same. So we have 14, so x minus 5 also has to equal 14, and then over here also has to be 14. So let's go ahead and solve this. I'm going to go ahead and rewrite it. X minus 5 equals 14. Go ahead and add 5 to both sides. X equals 19. So the x itself equals 19. So we also want to find the perimeter of number 13. So since all the sides are the same, what we could do is 14 plus 14 plus 14, or if you want, since all three sides are the same, you could do whatever number you have and then multiply it by 3, because the triangle has the 3 sides. So if you like to just add all the sides together, go for it, or you can use the multiplication if you see that. Either way, you'll get the same exact answer. So one way or the other, adding or multiplying, our perimeter is 42. Alright, so you go ahead and try that out with number 14. I'll give you a couple seconds to look at it. Alright, so y equals 60. We got that. The x, there's a couple different things you could do. There's actually one other way. I just didn't include it because we're kind of focusing on just taking the angles and setting them equal to 60. I will talk about that other way, but here are the two ways that we had most likely done. You might have taken either angle, set it equal to 60. Since we were finding an x in both of them, they should equal the same, and they definitely did, but here's the proof no matter which way you went. Since all the angles are also equal, if you really wanted to, you could do 4x minus 12 equals 3x plus 6, because they both equal 60, so even though we're not quite sure what exactly x is, I do know that altogether this equals 60 degrees, so I could set them equal. But the biggest thing to remember is that each individual angle equals 60 degrees, so you could just set them equal to 60. Alright, let's go ahead and go to the next page. So number 15 is a challenge. So once again, I'm going to kind of give you guys a couple seconds to look at this one, try it, and then I will put it down and we can talk about it a little bit. Alright, so hopefully you've got a chance to try this challenge problem. So what ends up happening is we can create our two initial equations here, and we have x and y in both of them. So what I needed to do was either use some sort of elimination or substitution. I decided to go with substitution, but if you saw elimination, that is totally fine. Those y's can definitely cancel out one another, and you can solve for x, and then plug in and solve for y. I used substitution. I subtracted x from both sides, and so I now have y equals, and I was able to plug that in for my y right there. And then I went from there and solved for x, and then I plugged x in. That's where this green circle and arrow is. I plugged in x to solve for my y over there. Alright, so hopefully you were able to at least set those equations up and then recognize, well, I can't solve for them right off the gate, but you can solve for them either using substitution or elimination. Alright. Go ahead and take a look at 16 through 18 using this diagram here. So use the diagram shown below. You need to find x, find y, and the perimeter of ACD. Okay, so the first thing I notice is that these sides with all like the dashes are all the same. I'm going to go ahead and label that. Never be afraid to label your diagram the best you can, with all the parts that you know, even if you're not sure. So like these x's, I know that all of these angles are x degrees because it's an equilateral triangle. It's good to label it so you can see what you have and you can work with it. Alright, and then also, if we take a look at this triangle here, it is an isosceles triangle because we have two sides the same, which means this angle is y degrees. Okay. So we kind of labeled everything we know right off the bat without having to really do any math, just looking at the picture and matching up what matches with what. Alright, so our first thing is to find x. Well, my x is part of an equilateral triangle, so x has to equal 60 degrees. Or, well, 60, and then each angle is 60 degrees. Alright, now we want to find y. So I'm going to go ahead and draw or write 60 above each of these. So y, I have two y's, but I need to know what this angle is here. And so I can take, we have a straight line, so I can take 180 and subtract 60. I now have 120, so I know this angle is, let's use a different color, 120 degrees. Now I can use the triangle sum theorem. Y plus 120 equals 180. So we'll combine my two y's and then subtract 120 as well. Equals 60. So we did just end up in the same place that we were just at, but it's good to see. And then we have divide by 2, y equals 30. So I know that both of my y's equal 30. And if you wanted to double check, you can always add them up. So if we see we have, for the larger triangle, making sure that that equals 180, so the ADC triangle. Alright, I'm checking that out. Okay, so then we want to find the perimeter. So the perimeter is the outside of this whole triangle, and we know all the parts. We just have to add all the numbers together. So we do just have to remember that here is 4 plus 4. So this whole side is 8. So I have 4 plus 8 plus 6.93, which gives me 18.93. Alright, let's take a look at example 19. So 19, determine if x, y, z is isosceles or not. Use the distance formula as needed and show your work. So whenever we have a slant, we're going to have to use the distance formula, but x, y here, it's straight across, so I can count 1, 2, 3, 4, 5. That is 5 points away. Alright, let's go ahead and take a look at wx. And I'm also going to name the points so that we can use the distance formula. So x is -4, -4. W is -3, -1. And y is 1, -4. Okay, so wx, where if we use the distance formula, so square root of x2 minus x1, so -3 plus 4, so minus a negative number is plus, and then plus -1 plus 4 squared. Both of those, we end up with 1 squared plus 3 squared, which is 1 plus 9, so we end up with the square root of 10. So that means this here is the square root of 10. So far we're not at an isosceles triangle, but we still have one more side to check. So we're going to do wy, and we're going to use the distance formula again. So I'm going to take the square root. We have 1 plus 3, so -3 minus negative is positive, plus -4 plus 1 squared. We have 4 squared plus -3 squared, which is 16 plus 9, which gives me the square root of 25, which is 5. So I can plug that in. Yes, we do have an isosceles triangle. So you don't have to explain why. Your math shows why it is an isosceles triangle. Alright, and then our last one, example 20, find x and y in the diagram shown. So we know that both of these are x, because across from here is both x degrees. So let's start with finding x, because I notice I have a straight line, and I know I know that this outside angle is 113. So that means 113 plus x is equal to 180. So I'm going to subtract 113 from both sides, and I have x equals 67. So that means x equals 67 here and here. So now I can use the triangle sum theorem. Y plus 67 equals 180. Add those together. Y equals, not y equals, y plus, sorry. So we have y plus 134 equals 180. Subtract 134 from both sides. Y equals 46. Alright. And that is the end of 4.5. If you need to, you can watch this video as much as needed and make sure you're asking your teacher if you have any questions. Hope you have a great day. Bye.